Okay guys, so after watching me derive the quadratic formula, after viewing the other two parts of this lesson, you should be motivated and know why we need the quadratic formula to solve for x-intercepts of parabolas, mainly because we can't always factor to find these values because they're not always nice. Now, an extension of the quadratic formula is knowing how to just solve equations. So when I see, for example, a question like number 1, I can clearly see that it's not asking me to graph, it's not asking me for x-intercepts, but the setup of the formula is the same. So it's asking me for what the x values are when y is 0. So all I have to do is recognize that in the form ax squared plus bx plus c, in this case a is 2, b is 4, and c is -7. And then what I have to do is I have to take these values and I have to sub them into my quadratic formula. So a is going to go into here. Okay, b goes here, and c goes here. And I have to be really careful about making sure my signs are correct. Okay, so I will also post a handy video on how to memorize, or a song that helps you memorize the quadratic formula. It's pretty funny. But basically, all I have to do now is sub into a formula. It's pretty straightforward. Okay, so in the next step, we have to remember, if I'm asking you to solve exactly, we know that this is just root 36 root 2. Okay, and what I would do to simplify this is I would look at the -8 in the denominator, and I would change all of the signs to get rid of that -8. So we can now write this as +4 plus or minus is the same as minus plus over 8. And I can see that all of these factors are divisible by 2, so we might as well reduce it. Okay, so what that means is x1 is 2 plus 3 root 2 over 4, and x2 is 2 minus 3 root 2 over 4. So there we go. All right, so if I look at number 2, I actually see that I can't answer this question. And the reason is because it's not a quadratic equation. And the reason I can't answer this is because this is a function of x and y, and it's not asking me to solve for a specific value of x for a specific value of y. So I cannot actually use the quadratic formula Okay, the quadratic formula only works when I have ax squared plus bx plus c equals 0. And I actually don't know what y is in this case, so it's the whole entire function. So I actually can't answer this question. If I was given more information about y, for example, if someone told me that y is 10, I could sub 10 in and then move it over to the other side and create a function that looks like this, but with this, I actually cannot. Okay, let's look at number 3. So number 3, actually, again, it's not in the form where one side is 0. So first of all, we have to move the 20 to the other side. So now it's in the form ax squared plus bx plus c equals 0. Now I can see how easy this one is to factor. I'm not going to use a quadratic formula here. I can just do this, and I can see that my x1 value is 5 and my x2 value is -4 using the zero product property. So no need to use the quadratic formula when it's easy to factor. Okay, so let's have a look at this one. So for this question, guys, what you'll notice is that the thing underneath the square root ends up being negative. Okay, and this is a clue. So a negative under the square root, as we know, you can't simplify, at least not in this course. So what does that indicate about the graph? Well, in short, what that means is that there are no x-intercepts. So my parabola is going to look something like this. So when I get something like this, what I should say is that there are no x-intercepts. Or in other words, we can say there's no solution for this particular equation. Okay, so anytime you get something like this, please don't just stop writing or leave the rest blank. Your answer to this question is that there are no x-intercepts. So please clearly state that. Otherwise, I'm not going to be sure that you know what you're doing. Okay? So that's it for just practice problems with the quadratic equation. Mainly, you just have to know how to sub numbers in for letters, and how to reduce radicals. Okay, so let's go to a word problem. So we've already seen these problems. But what you'll notice is now we don't need to be given our function in vertex form. I can now answer all of the problems. At what time will the rocket rise to a height of 6 meters above the ground? Okay, so I recognize that this is a function that's modeling a toy rocket being launched from a 4.5 meter platform. So this is 4.5 meters, it's going up, it's coming down. The height of the rocket is modeled by the equation, where h is the height in meters above the ground, and t is the time in seconds. Okay, so at what times will the rocket rise to a height of 6 meters above the ground? So if x is 6, what is t? So now I have a quadratic equation, but just like when I use the zero product property, I always need one side to be 0, okay, if I'm going to use a quadratic formula, okay, because the quadratic formula is for intercepts, right? Okay, so we can see that there are 2 times where this rocket rose to 6 meters above the ground. So if we want to visualize this, we can picture it. Okay, so I can see that at the times the rocket was 6 meters above the ground, it was 0.217 seconds and 1.383 seconds. At what time does the rocket hit the ground? Your answer should be exact. Okay, I get a lot of questions about what that means. Well, we can see that in part A, I rounded to 3 decimal places. In part B, I'm not going to round at all. So let's see what that looks like. So if I want to know where it hits the ground, that's when height is 0. So again, I'm going to use the quadratic formula to answer my question. So the exact answer here would mean that all I have to do is not evaluate square root of 154. So for my answer to be exact, I need to leave it like this. Okay, now if I look at this, I can actually see that T1 doesn't work because T1 is going to give me an overall negative answer. And I know that time can't be negative. Whereas T2, I'm going to have, if I evaluate this, the overall value will be positive. So I can see that this actually is my final answer for part B. So if we look at part C, it's asking us for the maximum height of the rocket. And hopefully you have all watched the video that I marked must watch, because something we learned is that if I want to find the vertex of a parabola in standard form, I know that xv is negative b over 2a. And if I want to find yv, I just have to sub xv back into my function. Okay, so if I'm given, in this case I have y equals negative 5, t squared plus 8t plus 4.5. In order to find my t vertex, all I have to do is sub in negative 8 over 2a. Okay guys, so let's keep in mind that the vertex can be found, vertex of any parabola can be found using these two equations. Okay, last question of this lesson. Okay, so if I want to figure out the points of intersection of these two parabolas, I can think of them as a system. And in order to solve for the points where they intersect, I can just set y equal to y. So I can see that this is taking the form of a quadratic equation ax squared plus bx plus c set equal to 0. So I'm allowed to use a quadratic formula. So let's do it.